Why does light slow down in glass? You know the answer. Everyone knows the answer. Light hits glass, light slows down. Vacuum speed, 299,792 kilometers per second. Glass speed, maybe 200,000. Simple physics. Wrong. Not a little wrong. Fundamentally, beautifully, catastrophically wrong. Here's what should disturb you. Right now, inside every window, every lens, every fiber optic cable on this planet, photons are traveling at exactly 299,792 kilometers per second. Full speed, always full speed. C does not negotiate. C does not bend. C does not care what material you put in front of it. So what the hell is actually happening? Look at any glass near you, right now. A window, your spectacles, that phone screen 3 inches from your face. You're not seeing slow light. You're seeing the greatest illusion in physics. Electrons are dancing. Waves are canceling. Quantum probability is rewriting what speed even means. And I spent decades untangling this beautiful mess. Here's what nobody told you in school. When you truly understand why light slows in glass, you'll understand why matter isn't solid, why atoms are mostly empty, why reality itself is not what your eyes report. Everything changes after this. Let me show you. You've seen this trick your entire life. You just never recognized it. Grab a glass of water. Seriously, do it right now. Stick a pencil in it. Look at the bend, that kink where straight becomes crooked. Your teacher said, light slows in water. That's why it bends. Beautiful explanation. Completely wrong. Here's the thing nobody mentions. If light actually slowed down, like a car hitting mud, it would lose energy. It would get tired. The color would shift. Red light in, redder light out. Does that happen? No. Light enters glass, light exits glass. Same color, same energy, same photon. Nothing got slower, nothing got tired, nothing lost anything. So what did happen? Think about your eyeglasses. 2 curved pieces of glass. They bend light so precisely that blurry becomes sharp. Billions of people depend on this slowing every single day. Think about fiber optics. Right now, right this second, your internet is traveling through glass threads, thinner than hair. Light bouncing inside, carrying your data across oceans. Think about diamonds. Why do they sparkle? Because light slows so dramatically inside that it bounces around, splitting into rainbows, creating fire. All of this works. All of this is real. But the explanation, the light slows down story, that's a children's tale. A useful lie we tell, because the truth is harder. And here's where I need you to pay close attention. The truth isn't just harder. The truth is weirder. The truth involves something happening at the atomic scale that will make you question what moving even means. Hold that thought. Let me take you inside the glass. Not metaphorically, actually inside. Shrink yourself down, smaller than dust, smaller than a cell, smaller than a molecule. Now look around. What do you see? Nothing. Almost nothing. Glass looks solid from outside. From inside, it's mostly empty space. Atoms floating like tiny solar systems, huge gaps between them. If an atom were a football stadium, the nucleus would be a pea on the 50-yard line. That's what solid actually looks like. Now here comes a photon, a single particle of light, moving at c, full speed. Nothing can stop it. And here's what happens next. The photon doesn't slow down. The photon gets absorbed, gone. An electron in one of those atoms swallows it, takes its energy, gets excited, jumps to a higher orbit, holds that energy for a fraction of a second. Then, the electron spits out a new photon, same energy, same direction, full speed again. That photon travels until another electron grabs it, absorbs it, holds it, releases it again. and again, and again, billions of times between one side of the glass and the other. You see what's happening? Light isn't moving slow through glass. Light isn't moving through glass at all. Light is being eaten and reborn, eaten and reborn, eaten and reborn. A relay race, not a marathon. Each photon sprints at full speed, but between sprints, there's a pause, tiny, microscopic, but real. Add up all those pauses, trillions of them, and what do you get? A delay. Not slower light, delayed light. The photon that exits your window is not the photon that entered. It's the great-great-great-grandchild, a million generations later. Same energy, same message, different particle. That's not slowing down. That's resurrection. And it gets stranger. Now here's where your brain will fight you. Because what I just told you, absorption and re-emission, that's the simple version, the version you can picture. The real version is quantum. And quantum doesn't care about your pictures. See, I lied to you a little. Not badly, but a little. When I said electrons absorb photons and spit them back out, that's true. But it's not the whole truth. Here's the whole truth. When light enters glass, it doesn't just interact with one electron. It interacts with all of them, simultaneously. Every electron in every atom in the entire piece of glass becomes part of one giant quantum dance. Wait. The incoming light wave shakes those electrons, gets them vibrating. And vibrating electrons do something interesting. They create their own light waves, new waves, secondary waves, coming from every atom, overlapping, interfering, adding, canceling. Picture this. Drop a stone in a pond, ripples spread out. Now drop 1,000 stones, 1,000,000 stones. The ripples crash into each other. Some peaks meet peaks, bigger waves. Some peaks meet valleys, nothing, flat water. That's interference. That's what's happening inside glass. The original light wave, plus millions of secondary waves from shaken electrons, all combining. And when you do the mathematics, when you add up all those waves properly, something magical emerges. A single combined wave, moving slower than c, not because any photons slowed, but because the pattern changed. The interference created an illusion, a collective illusion of slower speed. Let me say that differently. Individual photons, always at c. The wave pattern they create together, slower. It's like watching a stadium crowd do the wave. Each person stands and sits quickly, but the wave itself rolls slowly around the stadium. Same principle, different scale. And I discovered exactly how this works. Let me tell you how I figured this out. 1940s, World War just ended. Physics was broken open. We had the atomic bomb. We had quantum mechanics. But we didn't have a complete picture. Light and matter. We understood them separately. But together, how photons actually interact with electrons. A mess. Contradictions everywhere. Infinities in the equations that made no sense. I was young, obsessed, couldn't sleep some nights. And then I found it, not a formula, a way of seeing. I called it the path integral, the sum over histories, and it changed everything. Here's the idea. When a photon travels from point A to point B, it doesn't take one path, it takes every path, simultaneously. The straight path, the curved path, the crazy zigzag path that goes to the moon and back. Sounds insane. It's true. Each path has a probability. Each path has a phase. And when you add them all up, every possible history, every possible route, most of them cancel out. The crazy paths interfere destructively. Poof, gone. What survives? What remains? The classical path, the sensible path, the one Newton would predict. But here's the thing Newton missed. Those canceled paths, they're not nothing. They affect the final answer. They shape reality, even while disappearing. Inside glass, this matters enormously. The photon explores every possible route through every possible electron interaction. Most cancel, some don't. What emerges is that slower wave pattern, not because physics changed, because probability voted. Einstein showed time was relative. I showed paths were democratic. Every possibility matters. Every history counts, even the ones you never see. That's quantum electrodynamics. That's my life's work. And that's what's happening inside your window right now. Let me make this concrete. Imagine a stadium, 100,000 people. You're standing on one side. Your friend is standing on the other. You shout. But here's the rule. No one can let your voice pass through. Each person must hear your word, then shout it themselves to the next person. So you yell, "Hello!" First person hears it, processes it, shouts it forward. Next person, same thing, next, and next, and next. Eventually, your friend hears, "Hello!" on the other side. Now, did sound slow down? No. Every single shout traveled at the same speed, sound waves moving at 343 meters per second, always. But the message? The message arrived late because of all those tiny pauses, all those little processing delays between hear and shout. That's light in glass, exactly that. Photons screaming at full speed between atoms, but pausing just for an instant at each electron interaction. The message gets delayed, not the messenger. And here's the beautiful part. The more atoms in your way, the more pauses, the more delay. That's why diamond slows light more than glass. More electrons, more interactions, more tiny resurrections, not thicker mud, busier relay race. Do this right now. Whisper a word. Listen to it leave your mouth. That sound never slowed, neither does light. Now let me show you something worth billions of dollars. Fiber optics. Right now, this exact second, light is bouncing through glass cables under the ocean, carrying your texts, your videos, your bank transfers, every meme, every email, every desperate 3 a.m. Google search, all of it through glass at almost the speed of light. Here's the part that should bother you. If light actually slowed down in glass, like a car in mud, fiber optics would be terrible. The signal would degrade, information would smear, your Netflix would buffer forever. But it doesn't. Why? Because the photons aren't tired. They're not fighting resistance. They're not pushing through thick material. They're sprinting, pausing, sprinting again. Perfect relays, no energy lost. Now look at diamonds. A diamond's refractive index is 2.4, meaning light slows to less than half its vacuum speed inside. Except it doesn't. Photons inside diamonds still travel at sea. But so many electrons, so many interactions, so many tiny quantum handshakes. The delay stacks up, the wave pattern crawls. That's why diamonds sparkle. Light bounces inside longer, splits into colors, creates fire. Billion-dollar jewelry industry built on an illusion. Your phone screen, your camera lens, your bathroom mirror, all using this trick. Technology that works perfectly because the slowing was never real. Now let's go somewhere extreme. Here's where physics gets dangerous. Cherenkov radiation, you've seen it, that eerie blue glow inside nuclear reactors, ghostly, haunting, beautiful. Know what causes it? Particles moving faster than light. Wait, didn't I say nothing moves faster than C? Didn't Einstein prove that? Yes and no. Here's the trick. Nothing moves faster than light in a vacuum, but in water, in glass, the effective light speed is slower. That wave pattern we discussed, the illusion. So a particle, say an electron from nuclear decay, can enter water moving in 99% of C. Vacuum light speed, untouchable. Water light speed, beatable. The electron outruns the light wave pattern, and when it does, boom, sonic boom, but for light. The electron creates a shock wave of photons, a cone of blue light spreading behind it. Same physics as a jet breaking the sound barrier. Same math, same geometry. That blue glow is proof. Proof that slow light is really just delayed waves. Because if light actually slowed, if photons themselves moved at reduced speed, nothing could ever overtake them. But particles do, regularly, in every nuclear reactor on Earth. The illusion breaks. Reality peeks through. Cherenkov radiation, the universe's confession that light speed in materials was never about light slowing. It was about waves lying. And now, the deepest truth. So what have we actually learned? Let me pull this together. Light doesn't slow down in glass. Photons always travel at c. What changes is the pattern, the collective wave behavior, the quantum probability landscape. But here's what that really means. You think glass is solid. It's not. It's mostly empty space with electrons scattered like dust. You think light is a thing. It's not. It's a probability, a likelihood, a quantum whisper that only becomes real when something measures it. You think speed is simple, distance over time, easy, wrong. Speed at the quantum level is a story we tell ourselves, a useful approximation, a convenient lie. The photon doesn't know it's going slower. The photon doesn't experience delay. The photon doesn't experience anything. There is no photon, not really, not the way you imagine. There's a quantum field, excitations in that field, probability waves rippling through empty space. And when those waves hit matter, when they dance with electrons, the probability pattern shifts. The wave function evolves differently. That's all slowing is. Probability updating, reality recalculating, the universe doing mathematics. You're not looking through a window. You're looking through a probability filter, a quantum computation happening in real time. Every piece of glass, every drop of water, every transparent thing you've ever seen, not slowing light, rewriting reality. And you've been watching this miracle every single day without knowing, until now. So here's where I leave you. Tomorrow morning you'll wake up, sun will hit your window, light will pour through, and now you know, that light didn't slow down, those photons didn't get tired, nothing moved through mud. 1 trillion quantum resurrections happened, electrons danced, probability waves interfered, reality recalculated itself, just so you could see the sunrise. Every window is a miracle machine. Every glass of water is a quantum computer. Every transparent surface is the universe confessing its deepest secrets. You just never had the ears to hear it. Now you do. I spent my life chasing this, pulling threads, asking stupid questions that turned out to be profound. And the biggest lesson? The obvious stuff isn't obvious. The simple explanations are usually wrong. And the universe, when you look closely, is far stranger than any story humans invented. Light doesn't slow in glass. Reality bends. Probability dances. And you, sitting there right now, are made of the same quantum weirdness. You're not separate from this. You are this. So next time you look through a window, remember what's really happening and wonder what else you've been seeing wrong. I certainly did.